Hi all, welcome to the 7th lecture on mechanics of machinery. In the last lecture, we discussed about the inversion of Fauber mechanism. In this lecture, we will discuss about the inversions of a slider crank mechanism. From the academic point of view, these two are the mechanisms which are important, strictly from the subject point of view. Okay, so let's start with the slider crank mechanism. So first I will explain what is a slider crank mechanism. We can go to the various inversions of slider crank mechanism. Slider crank mechanism consists of four links: the crank, connecting rod, slider and the fixed link which is the frame. In this case, this is the crank which is rotating, which is making a complete revolution. This is the slider which is making a reciprocating motion, and the slider and the crank are connected by the means of a connecting rod. And this cylinder, this is the fixed one which is called as the frame. Cylinder is the fixed one which is called as the frame. Piston, it is a moving pair, it's a reciprocating pair. The crank is a revolving pair, the crank is rotating and the crank and the piston is connected by the means of a connecting rod. If you look at this figure or the animation, you can see that in a slider crank mechanism there is one sliding pair and all the others are turning pairs. Okay, so it consists of three turning pairs and one sliding pair. The crank here is connected by the means of a turning pair, the crank and connecting rod by the means of a turning pair, the connecting rod and piston by the means of a turning pair. Whereas the piston and the fixed one, that is the cylinder, consists of the sliding pair. Okay, so the link 1 in this figure, the link 1 corresponds to the frame, link 2 corresponds to the crank, link 3 is the connecting rod and link 4 is the piston which is the moving part. Okay, so this is the slider crank mechanism. Now let us go into the various inversions of slider crank mechanism. As I already told in the previous lecture, the inversions can be obtained by fixing different links in a mechanism. Here also in slider crank, there are 4 links and so we can obtain 4 inversions by fixing different links. The first one is the pendulum pump or the bull engine, oscillating cylinder engine, rotary internal combustion engine and crank and floater lever quick return mechanism. These are the 4 main inversions of slider crank mechanism. Let us come to the first one, the bull engine or the pendulum pump. Again, animation is more than enough to explain this thing. So this is the another figure of a bull engine. See, first you need to mention which link is fixed in this mechanism. That is the first thing. As I already explained, here we need to explain which link is fixed, what are the various other links and what is the basic function. In this figure or in this animation, you can see that the link 4 is fixed. Okay, the link 4, with that is the cylinder is fixed, that is the sliding pair is fixed. And you can see that when the crank rotates, the connecting rod oscillates and that is transferred to the piston. Okay, so this is the basic functioning of the pendulum pump or a bull engine. Again, here the rotary motion of the crank is converted to the reciprocating motion of the piston. In the animation, you can see that there are 2 pistons, one on the top and other on the bottom. This is also a variation of the pendulum pump. This is also called as the duplex pump, where 2 pistons are present. Whereas in this figure, there is only one piston. This is also the pendulum pump or the bull engine. If there are 2 pistons, then it is called as the duplex pump. Anyway, the basic functioning is, or the basic function or the basic explanation is same for both the cases. So again in pendulum pump or bull engine, the cylinder is the fixed one. It converts the rotary motion to reciprocating motion and then you need to explain the mechanism. That is, the crank rotates and the connecting rod oscillates and that oscillation is transferred to the piston, reciprocating movement of the piston. Okay. So, this is the pendulum pump or the bull engine. Next one is the oscillating cylinder engine. So, this is the figure of an oscillating cylinder engine. If you closely look at the animation, you can see that the cylinder that is actually oscillating. That is why it is called as the oscillating cylinder engine. And in this mechanism, the link 3 forming the turning pair is fixed. That is, the connecting rod is fixed. The connecting rod part is fixed. You can look at this figure and you can get a clear idea. The connecting rod is fixed. When the crank rotates, this is the crank, here this is the crank. So, when the crank rotates, the piston attached to the piston rod reciprocates, okay, and the cylinder oscillates about a pin. The cylinder oscillates, that is why it is called as the oscillating cylinder engine. So, you need to mention which one is fixed. In the oscillating cylinder engine, the connecting rod is fixed, the crank rotates and the piston reciprocates and the cylinder oscillates. So, this is the 2D drawing and this is the animation. This is also the 3D, another 3D drawing of the oscillating cylinder engine. I think animation will give a clear idea. Okay, the cylinder actually oscillates. You can clearly see from the animation, that is why it is called as the oscillating cylinder engine. And the third one is the rotary internal combustion engine or GNOM engine. So, this one actually in a rotary internal combustion engine or GNOM engine, there are 7 cylinders. There are 7 cylinders. Okay. So, it consists of 7 cylinders in one plane and all revolves about the fixed center. In this mechanism, you can see that actually the crank is the fixed one. See, look into this animation. This is the crank. Okay, this blue portion, this is the crank. This is the fixed portion. This is the fixed link. The connecting rod rotates and the piston reciprocates inside the cylinder. Okay, so this is what happening here. The crank is the fixed one. In this figure, the link 2, which is the crank, and that is the fixed one. The connecting rod rotates and the piston, which is the link 3, reciprocate inside the cylinder. Okay, the link 1 is not a fixed one because it is rotating, so it is not a fixed one. The cylinder, that is the link 1, it is not a fixed one, it is rotating. So, this is the rotary internal combustion engine. Here crank is the fixed one. Connecting rod rotates and because of that the piston reciprocates inside the cylinder. The whole thing actually rotates. This is the GNOM engine. Earlier, these type of engines are used in the aviation, but now it was replaced with gas turbines. Okay. So, let us move to the last one, crank and slotted lever quick return mechanism. I think you will see this in our machine tools lab in the shaper. In our shapers, the shaping mechanism is actually the quick return mechanism. Okay. Why it is called as quick return mechanism is, when you closely look at this animation, you can see that on one side of the movement, see, look at this animation here. This is a forward stroke. Here it's during the forward stroke, this is moving slowly, whereas in the return stroke it is moving, it is reciprocating quickly. That is why it is called as the quick return mechanism. You just closely look at this animation. During the forward stroke, now you know, look at this. This is the forward stroke. Here it is moving slowly, whereas in the return stroke it is moving quickly. That is why it is called as the quick return mechanism. So, this is another figure for the quick return mechanism. In this mechanism, the link AC, that is the connecting rod, here also the connecting rod is fixed. Sorry, here the connecting rod is fixed, that is the link AC in this figure. See this one, AC, this is the connecting rod, this is the fixed portion. Now, when I explain the mechanism, actually the crank revolves with uniform angular speed, that is very important. The crank revolves with uniform angular speed. Here this is the crank, this one, the revolving one, this one is the crank. In this figure the CB is the crank. Now a sliding block is provided at a pin B that slides along the slotted bar. This is the slotted bar. This pin slides when the crank rotates. This pin slides along this slotted bar, and because of this, and thus the AP oscillates. This AP means this slotted bar actually oscillates. Now a short link, this connects this to the ram. This is the ram, and this oscillatory motion of the slotted bar is transferred to the ram, and so the tool is attached at the end of the ram. Maybe the tool is attached here. So when the slotted bar oscillates, the ram also reciprocates and the tool performs the forward and return stroke. That is the cutting stroke as well as the return stroke. So this is the basic mechanism. In this mechanism, the connecting rod is the fixed portion. The crank rotates, and through a pin it is connected to a slotted bar. When the crank rotates through this pin, the slotted bar actually oscillates, and this oscillation is transferred to the ram where the tool is fixed. So the tool executes the forward as well as the backward stroke, that is the cutting stroke as well as the return stroke. So this is the basic crank and slotted lever mechanism. Normally tool is attached at this point, that is at the end of the ram, this point. This is the forward stroke where the tool is moving slowly. In the return stroke, this is the return stroke where the tool is moving fastly, quickly. That is why it is called as the quick return mechanism. So again, this is the detailed figure. In this one, CB is the connecting rod, AC is the connecting rod, CB is the crank, and AP is the slotted bar. Through this thing, it is connected to the ram and it executes the cutting stroke as well as the return stroke. Okay. So these details I am explained in this thing. AC forms the turning pair is fixed, that is the connecting rod is fixed, the crank revolves, the slotted bar oscillates, and it is transferred to the ram. And one thing you need to notice is that during the forward stroke or the cutting stroke, actually it is rotating in the clockwise direction. So the forward stroke means from here to here, that is from CB1 to CB2. Return stroke means CB2 to CB1, that too in the clockwise direction. Both are in the clockwise direction. So return stroke means CB2 to CB1, and cutting stroke or forward stroke means CB1 to CB2. Now the time of the cutting stroke by time of the return stroke is equal to beta divided by alpha, or beta divided by 360 minus beta, because alpha plus beta is equal to 360 degree. And one thing you need to notice is that why it is called as quick return mechanism, that I already explained how this quick return mechanism is achieved. See, in this figure you can see that the beta angle is larger, whereas the alpha angle is smaller. Since the crank is rotating at constant angular velocity, the beta angle is larger, which means that the forward or the cutting stroke is lengthier one, whereas alpha angle is smaller, meaning that the return stroke, backward stroke is quicker. Because of this angle, beta is larger and alpha is smaller, because of this only this quick return mechanism is achieved. Okay. So I hope you have no doubt on what a quick return mechanism is and how this is achieved. Okay. Forward stroke, even if you look at the shaper mechanism, it's a quick return mechanism. During the cutting stroke or during the forward stroke, the tool moves slowly, whereas in the return stroke, where actually no cutting is taking place, that time the tool moves quickly back to the original position. So it is the quick return mechanism. So these are the four mechanisms, so four inversions of a slider crank. Again, one quick recap. So the inversions of a slider crank mechanism, this is the first one. Here cylinder is fixed. pump in the oscillating cylinder engine, which one is fixed? Connecting rod is fixed one. Connecting rod is the fixed one. And in the rotary internal combustion engine, crank is the fixed one. And finally, in the crank and floater lever quick return mechanism, again the connecting rod is the fixed one. Okay. So, these are the 4 inversions of a slider crank mechanism. Please watch the video during the online sessions. Please watch the video and come up with the doubts. Actually, it is not an explanatory session. You need to watch the video, you need to understand the thing, you need to go through the PDF, then come for online discussion. Actually, it is called as a discussion panel, not again a teaching panel. So, I hope you understand all the things. Vipin Gopan signing off. Thank you.